Hello students. In the previous class, we have already started with complement of a set. So just to make you fresh with that, suppose A is subset of U, then A complement will be having X elements such that X is subset of U but not X belongs to U, but X does not belong to A. Or you can write it as U minus A also. For example, if U is having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A is having just 1, 3, 5, 7, 9. A complement from you remove what all elements are there in A 1, 3, 5, 7, 9. Left of is 2, 4, 6, 8, 10. This is only A complement. Similarly, one more example. If U is the set of all students of class 11 and A is the set of girls of class 11. If you want to find A complement from all students of class 11, you have to remove the girls of class 11. Then you are left with only boys of class 11. This is A complement. So similarly, we have results for A union B whole complement and A intersection A complement intersection B complement. We can find out all these also. Suppose I will give you 1, 2, 3, 4, 5, 6. A as 2, 3. B as 3, 4, 5. Then A complement from U remove 2, 3. Left is 1, 4, 5, 6. B complement is from U you remove 3, 4, 5. Left is 1, 2, 6. Next, take intersection of A complement and B complement. The common thing in both is just 1 and 6. Next, we will find A union B. First, I will write the elements of A, then I will write the elements of B. Now, if I take A union B whole complement, from the U, you have to remove 2, 3, 4, 5. That means left is 1, 6. So, from these two, you can observe that A union B whole complement is same as A dash intersection B dash. This is what we have proved. Similarly, you can also prove A intersection B whole dash will be equal to A dash union B dash. These two, that is A union B whole dash equal to A dash intersection B dash. These two are called De Morgan's law. These two you can name them. Now, A complement can be represented by Venn diagram also. Take the set U, in that draw the set A. A complement means take U, but don't take A. Don't shade the circle A at all. You have to take U, but not A. So this shaded diagram represents A dash. There are some properties in complement also, properties of the operation complement. That is, first one is complement loss. According to complement laws, there are two laws, A union A dash will be equal to U, and A intersection A dash is empty set, these two. Then as I told you, De Morgan's law. There are two laws again. A union B whole dash is A dash intersection B dash. A intersection B whole dash is A dash union B dash. Then law of double complement. You can take the complement twice. That is A dash whole dash. And then it will be equal to A. Next is laws of empty set and universal set. They are phi dash will be equal to U and U dash will be equal to phi. So this is all about the complements. Next we can go to exercise 1.5, in which we will be doing problems based on complements. The first question is, the universal set U is having 1, 2, 3, 4, 5, 6, 7, 8, 9. Then set A is having 1, 2, 3, 4. B is having 2, 4, 6, 8. Lastly, C is having 3, 4, 5, 6. Now, first you have to find A dash. That means from U, remove 1, 2, 3, 4. Left is 5, 6, 7, 8, 9. The second one is to find B dash. That means from U, you remove 2, 4, 6, 8. Left is 1, 3, 5, 7, 9. Next, third one is A union C whole complement. So first of all, A union C, write the elements of A, write the elements of C. You have to take complement of this entire thing. That means from universal set, remove 1, 2, 3, 4, 5, 6. Left is 7, 8, 9. Fourth one is A union B whole complement. Write the set A union B. First write the set A. 1, 2, 3, 4. Then B. 2, 4 I need not write again. 6, 8. And then you have to take whole complement. That means from U, you have to remove 1, 2, 3, 4, 6, 8. Left is 5, 7, 9. Next, the fifth one is A dash whole dash. So first of all, A dash. A dash already we found here. So I will write 5, 6, 7, 8, 9, for which I will take complement again. So from U, you remove 5, 6, 7, 8, 9. Left is 1, 2, 3, 4. So this is A dash whole dash, which is A again actually. The sixth one is B minus C whole dash. From B, you remove 3, 4, 5, 6. 3 you can't remove. 4 and 6 you can remove. 3 and 5 you can't remove. So you will have 2 and 8, whose complement you have to find. So from you remove 2 and 8. 1, 3, 4, 5, 6, 7, 9. This is what you have for B minus C whole dash. Let's go to question number 2. In question number 2, U is having A, B, C, D, E, F, G, H. A is having A, B, C. B having D, E, F, G. C having A, C, E, G. And D having F, G, H, A. You have to find A complement, B complement, C complement, and D complement. A complement means in the set U, forget or remove A, that is A, B, C. Left is D, E, F, G, H. B complement means from the set U, remove D, E, F, G. So left is A, B, C, H. C complement is from the U, remove the set C. A, C, E, G. So left is B, D, F, H. Okay, next is D complement. From U, you remove the set D, F, G, H, A. So left is B, C, E, G. F, G, H, A you have to remove. F, G, H, A. So you will have B, C, D, E. That is D complement. Now next, question number 3. The set of natural numbers, that is 1, 2, 3, 4, 5. This is only universal set. And now you have to write complement of. The question is, write complement of. The first one, x such that x is an even natural number. So if you take this as A dash will be remove even natural numbers. Left is odd natural number. Okay, next. Second one, take the set B as x such that x is an odd natural number. So when you want to find B dash, you will remove odd natural numbers. Left are even natural numbers. So B is the set having even natural number. Third, let us take C. x such that x is a positive multiple of 3. If you take c dash, you will get x as not a multiple of 3, because you will be removing positive multiple of 3. Next, fourth one, D is the set having x such that x is a prime number. And D complement will be x such that x is not a prime number. Let us take to fifth one. That is E set x such that x is a natural number divisible by 3 and 5. So if you find E complement, so you will have x such that x is a natural number not divisible by 3 or 5. Sixth one, the set F is x such that x is a perfect square. So when you take F complement, you will have x such that x is not a perfect square, because all the perfect squares we have removed. So left is not a perfect square. Seventh one is G is the set having x such that x is a perfect cube. So G prime you will have x such that x is not a perfect cube. Next one is eighth one, the set H. X such that x plus 5 equal to 8. So H dash will be, here you will get x equal to 3. So x such that x is not equal to 3, you have to take in H dash. Next, ninth one, the set J is x such that 2x plus 5 equal to 9. So x will be 4 over 2, that is 2 in the original set. But in J, if you take J dash, you will have x such that x is not equal to 2. 10th one, K is a set having x such that x is greater than or equal to 7. So K dash will be a set with having x such that x is less than 7. Question number 11. L is a set having x such that x belongs to set of natural numbers and 2x plus 1 is greater than, just greater than 10. So L dash, you can write X such that X belongs to N. Here, X we will get greater than 9 over 2. So now you can take X less than or equal to 9 over 2. So with this, we have completed question number 3. Coming to question number 4. U is the set having 1, 2, 3, 4, 5, 6, 7, 8, 9. The set A has 2, 4, 6, 8, and the set B has 2, 3, 5, 7. First, you have to verify that A union B whole dash is A dash intersection B dash. So I will write A union B. I will write the elements of A, then elements of B. That is 3, 5, 7. Then I will take A union B whole dash. So after removing 2, 4, 6, 8, 3, 5, 7, the elements we have are 1, 3, 5, what else? A union B whole dash. You have to remove the elements of A union B from U. That means you have to remove 2, 4, 6, 8, 3, 5, 7. So you will be left with 1, 3 you have to remove. 2 and 3 you can't write. You have to remove 2 and 3. What else you will remove? You will remove 4, 5, 6, 7, 8. So left is just 9. That is A union B whole dash. Next we will take A dash intersection B dash. A dash is from U, you remove 2, 4, 6, 8. 1, 3, 5, 7, 9 intersection B dash. From U, you remove 2, 3, 5, 7. Left is 1, 4, 6, 8, 9. Now find intersection. The common thing, only common is 1 and 9. So from this you can say A union B whole dash 1 comma 9 is same as A dash intersection B dash. One of the De Morgan's law. Next we will take second one. They're asking you to verify A intersection B whole dash is equal to A dash union B dash. First I will take A intersection B. Common in A and B, only 2 is common. Now when you take A intersection B whole dash, from universal set you have to remove only 2. You can keep remaining 1, 3, 4, 5, 6, 7, 8, 9. That is A intersection B whole dash. Now already we found A dash and B dash. We will take union of both. A dash union B dash. That is 1, 3, 5, 7, 9 union 1, 4, 6, 8, 9. And when you take union, first I will write 1, 3, 5, 7, 9. Then I have to write 1 already written, 4, 6, 8. So you can see this and this are same. That means you have verified A intersection B whole dash is A dash union B dash. Let's go to question number 5. Drawing Venn diagram. First one, you have to draw A union B whole dash. So take the union box, draw A union B. A union B is this. A union B whole dash means don't shade A union B. Except A union B, you can take all. Next is A dash intersection B dash. So for this, you will take U, circle A, circle B. This is A intersection B, right? But we are not supposed to find A intersection B. What do we have to find? A dash intersection B dash. So first I will take A dash. A dash means I will not color A. I will not shade A. That means except A, I can shade anything else. Okay, now after that, I have shaded A dash. Except A, I shaded everything. Now you have to shade B dash. Except B, you have to shade everything. I shaded B. I should not shade B. B dash means except B, you have to shade everything else. Don't shade B. That is what it is saying. So I will not shade the B circle. Except B circle, I will shade everything. So what are you seeing? The shaded region you are seeing here is this is the shaded region, final shaded region. This is A dash intersection B dash. The double shaded region you are seeing. So from these two, you can say A union B whole dash is same as A dash intersection B dash. That is De Morgan's law. Next, third one, you have to shade A intersection B whole dash. So I will take the union set, universal set, and I will take the set A and B. This is A intersection B. So I will shade everywhere, but I will not shade A intersection B. Except A intersection B, I am shading everywhere. So this diagram is A intersection B whole dash because I did not shade A intersection B. The next is A dash union B dash. This is universal set. This is set A. This is set B. So first, A dash. Don't shade A. apart from A, shade everything else. Now union B dash. Don't shade B except B circle, shade everything else. So this is A dash union B dash. We can see from the two, A intersection B whole dash is same as A dash union B dash. With the help of diagrams also, we have proved De Morgan's law. Next is question number 6. In question number 6, U is the set of all triangles in a plane. Now A is set of all triangles with at least one angle different from 60 degrees. What is A dash? Because A, you are taking one angle different from 60 degrees. So in B, all angles are 60 degrees. That means A dash is the set of equilateral triangles. Because A, one angle not 60 degrees. At least one angle. That means maybe one angle is not 60 degrees, maybe two angles are not 60 degrees, maybe all the three angles are not 60 degrees. So this does not happen means all angles should be 60 degrees. That will be A complement. Next, 7th. First question is, what is A union A dash? A union A dash will be universal set. Second, what is phi dash intersection A? Phi dash means universal set intersection A. So it will be universal set. But you have to take intersection, not union. Phi dash is universal set. Common between universal set and set A. What will be common? It will be set A only, isn't it? Third one. A intersection A dash, nothing common. So empty set. U dash intersection A. U dash is empty set intersection A. So common between empty set and A will be empty set only. So with this, we have completed this exercise 1.5. Before going to 1.6, we have some practical problems on union and intersection of the sets. I think now we can do that. Before we complete the time, before the time we can complete this theory part. Suppose I will take A and B, two sets. And if A intersection B, nothing common between A and B, it is empty, then I can say number of elements in A union B will be just the sum of number of elements in A and number of elements in B. This is the first case. But if A intersection B is not empty set, then the number of elements in A union B will be number of elements in A plus number of elements in B minus number of elements in A intersection B. Now I can write this in another way. If I have n number of elements in A union B, it is nothing but number of elements in A minus B plus number of elements in B minus A plus number of elements in A intersection B. This way also we can write. Now the other one is number of elements in A union B union C is number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A, and finally you will be adding number of elements in A intersection B intersection C. So these are the formulas which we are going to apply in practical applications. For example, question number 1. X and Y are two sets. X union Y, number of elements in X union Y is 50. Number of elements in X is 28. Number of elements in Y is 32. You have to find number of elements in X intersection Y. So you have to take the formula n of X union Y is equal to n of X plus n of Y minus n of X intersection Y. This formula, because you know that n of X union Y is 56, n of X is 28 and n of Y is 32. We don't know n of X intersection Y. So n of X intersection Y will be 28 plus 32 minus 56. Oh, this is not 56. It's looking like 56. It is minus 50. So that means 60 minus 50, which is 10. This is how we can answer the questions in this manner. Now, second one. Second question. In a school, there are 20 teachers who teach maths or physics. Maths or physics, number of teachers, 20. Of these, 12 teach maths. Number of teachers teaching maths, 12. 4 teach both physics and maths. Number of teachers teaching maths as well as physics. That is 4. How many teach physics? Number of teachers who teach physics, that you have to find. So you can write the formula n of m union p equal to n of m plus n of p minus n of m intersection p. So m union p is 20, m is 12, n of p we don't know, but intersection we know. N of m intersection p. It is 40. So 20 minus 12 plus 14 is n of p. 8 plus 14 or n of p is equal to 22. We'll go to the next question, that is question number 3. In a class of 35 students, so total 35 students are there, 24 like to play cricket. Number of students liking cricket, 24. 16 like to play football. Number of students who like football, 16. Each student likes to play at least one of the two games. That means every student will be playing at least one or two games. But there is no student who doesn't play at all. That means N of C union F. Total, we have 40 students. But in class, they did not give you 40. They said total number of students is 35 in class. So how many students like both? Number of students who like cricket and football. C intersection F. So the formula is N of C union F is equal to N of C plus N of F minus N of C intersection F. Because C union F is 35, N of C is 24. We are given, we can use N of C as 24. N of F is given 60. N of C intersection F we don't know. So N of C intersection F will be 24 plus 16, that is 40 minus 35, that is 15. Sorry, not 15. It has to be 5. 40 minus 35 is 5. Okay, fourth question. In a survey of 400 students, total 400 students are there in the school. 100 were listed as taking apple juice. Number of students who take apple juice, 100. 150 take orange juice. Number of students taking orange juice, 150. 75 were listed as taking both apple as well as orange. 75 students take apple and orange both. Find how many students were taking neither apple nor orange. Neither apple nor orange. This you have to find. So first of all, I will take neither apple, neither orange means this. First of all, I'll take N of A union O. It is N of A plus N of O minus N of A intersection O. N of A is 100, N of O is 150, N of A intersection O is 75. So now we will get total 175. N of A union O. But because we have to find N of A dash intersection O dash, that means we have to find N of A union O whole dash. That means from the total, what is the universal set? From universal set N of U, you have to subtract N of A union O. N of U is 400. N of A union O is 175. Am I clear? So 10 minus 5, 5, 9 minus 7, 2, 3 minus 1, 2. So I will have 225 students who drink neither apple nor orange juice. So if you want, I can write U means total students. A means who take apple juice. O means who take orange juice. A intersection O, take both apple and orange juices. And A dash intersection O dash is take neither apple nor orange juice. For your convenience, I'm writing. Similarly, C means who play cricket. F means who play football. C union F, that means play cricket or football. Or you can say total students. C intersection means those who play cricket and football. Different meanings. Like here, this maths and physics, who teach maths or physics, or I can say total teachers. M means teach, who teach maths. M intersection P means who teach maths and physics. And P means who teach physics. Similarly, previous one we need not write because that is not a story problem. If you want, for every story problem, I will be writing sentences like this so that you can understand. Fifth one. There are 200 individuals with skin disorder. So total having skin disorders, whatever being, that is 200. 120 had been exposed to chemical C1. Number of people exposed Those who are exposed to chemical C1, they are 120. Then 50 people are exposed to chemical C2. Exposed to chemical C2. And 30 to both chemical C1 and C2. 30 people exposed to C1 and C2. Exposed to both chemicals C1 and C2. Find the number of individuals exposed to. Find the number of people who are exposed to chemical C1 but not chemical C2. So for all such questions, universal set and Venn diagram will be applicable. It will be easy. See, total 200 are there. Now this is C1 set. This is C2 set. In C1, 120 people, C2, 50, and intersection 30. So here it will be 120 minus 30, that is 90 people. Here it will be 50 minus 30, that is 20 people. So we have 90, 30, 120 and 20. 140 we have. Apart from 140, there are 60 people outside. So what they're asking, infected by C1 but not by C2. That means I have to take this. And so it will be, for the first one, answer will be 90. Using Venn diagram, you can say that. But if you don't want to use Venn diagram, how will you do that? How will you write that? I have told you with the Venn diagram. So number of people infected by C1 but not C2, not C2. C1 and not C2. This is what you will take. Is that clear? So how will you find this? This will be difficult. That's why we have used this one. Using this will be difficult. That's why I told you easy method is Venn diagram. Okay, second one. I will use a different color for second one. Number of people who are infected by chemical C2 but not chemical C1. So they are infected by chemical C2 but not C1. We are not taking C1 at all. We are not shading it. So how many people? 20. Isn't this easy? Using the Venn diagram? Okay, third one. Number of people who are infected by chemical C1 or chemical C2. That means this is union, C1 union C2. So 90 plus 30 plus 20. Total you will have 140. Using Venn diagram, it is very, very easy. For all such problems, we will be using Venn diagram only. Now we can start exercise 1.6. But this we will continue in the next class. Because if I start it, maybe we will be doing only one question or two questions. If you want, we will do the same sum, question number 5, without a Venn diagram in the meantime, because we have 6 minutes left. So what I will do is, in Venn diagram, simultaneously, I will give you Venn diagram. Universal set, total 200. Then this set infected by chemical C1, infected by chemical C2. Here I will have C1 minus C2. Here I will have C2 minus C1, this area. And this region is C1 intersection C2. Remember that. If you remember this, it will be easy. So for the first one, people exposed to chemical C1 but not chemical C2. That means what? What we have to find? Number of people infected by C1 but not C2. This is what we will find. Okay, how will you find this? What is the method to find? If you take n of C1 minus C2, n of C1 intersection C2, and n of C2 minus C1, you will get n of total. Isn't it? You will get n of C1 union C2. This is what you will get it. Like that, is there any relation which can help us to find n of C1 minus C2? How can I write n of C1 minus C2 in another way? I will take n of C1. From that, I will remove n of C1 intersection C2. Then I will get n of C1 minus C2. This is another way. So n of C1, how many are exposed to chemical C1? 120. So I will write 120. How many are exposed to chemical C1 as well as C2? In the question, both the chemicals, 30. So I will write 30. If I subtract, I will get number of people infected by C1 but not by C2. That is 90. Without Venn diagram, taking just the help of Venn diagram, I have done this. Okay. Now second one. Without Venn diagram is also easy, but only thing is you must have proper knowledge about the diagram. Then it will be easy. Okay. What is the second one? People exposed to C2 but not C1. That means you have to find C2 but not C1. C2 minus C1. So how will I do? How will I get n of C2 minus C1? Take n of C2. From this you subtract n of C1 intersection C2. See the Venn diagram. So they gave us n of C2, those who are infected by chemical C2. They already gave us. It is 50. 50 people. So from 50 people, you subtract the 30 people, 20 will be the answer. The third one, people who are exposed to C1 or C2. Just now I told you, if you add C1 minus C2, add C1 intersection C2, and add C2 minus C1, you will get total C1 union C2. So for the first part, we got 90. Then C1 intersection C2 is 30. For the second part answer, we got 20. So when you take the sum of all, that is n of C1 union C2, you will get 140, as we got previously. So you can do this way also. In this way, we have completed the theory part. In the next class, we will do the last exercise of this chapter 1.6. With this, I am ending the class.